board. So here we go. So for week 4, here's what we see. So we are going to, yesterday we had no school. Today we're going to do notes and start practice on graphing systems of equation, solving systems of equation by graphing. Wednesday, we're going to finish up that work. Thursday, we're going to learn how to do it algebraically using substitution. And Friday, we will finish that work. So if I go inside of Tuesday, inside my major activity folders, I see the work in here. So I'm letting you know already at the beginning of class. Come on, let's click here. That, hey, if you could just get through numbers 1 through 10 today and finish 11 through 20 tomorrow, that's a great pace to be working at, okay? If you're able to finish more than 1 through 10 today, great, you're a little ahead for tomorrow. If you couldn't finish all of 1 through 10, we'll try and finish up some from homework, and hopefully you can finish 11 through 20 tomorrow. So again, I do have the blank notes here. So if you have a Chromebook, these notes might be easiest done right now by following along in your Chromebook and editing with Cami. So using Cami can be very powerful here. We're gonna essentially what I do on the smart boards, what you can do on Cami. So let's get started inside our notes. So, smart notebook. This lesson is being recorded, and I will try and get it posted later today. So I'm sorry this is slightly hard to read here, but what this says here is 2 or more linear equations together form a system. It's right nice for me, please, today. There we go. One way to solve a linear system of equations is by graphing each equation and look at the point where look for the point common to both lines. Sorry, it's a little hard to read there. Any ordered pair in a system that makes both equations true is a solution to the system. So I know this is slightly hard to read, definitely if you're taking your notes and don't have up the blank right now, so I will write it a quick summary. So 2 or more equations make a system. We can solve. So, wow, I'm still waking up a little bit today. Solve it by graphing both and seeing where they cross. So we're going to take the time to graph them and do this. Again, if you're having a little trouble seeing the board, you can hop on the Zoom. That's no problem at all. And yeah, if you're saying you're fine seeing where you are, you're fine seeing where you are. I should have an extra pen, yeah. There you go. You're very welcome. So we'll talk about some of the steps of graphing equations, because I know it might have been a little while since you graphed equations. And I'm going to graph mine by hand, but I'm going to show you how we can use technology tools to help us do this. So I'm going to use a line tool, just so you guys know. Cami does have a line tool as well. So if you're watching what I'm doing, where the line tool is on Cami is just slightly different than where it is on my smartboard. But it's not a big deal if you have trouble finding it or need help or support using Cami as you start doing your work. Just call me over and we'll get it figured out. If you still want to do it, paper and pencil, that's fine. The last way to do it would be with Desmos, but that's a little more annoying. How I'm going to want to see everything, and you're going to have to send me a lot or figure out how to organize very well quickly, which some of you might be able to do. I'm not saying I won't take it or you can't do it that way. I'm just saying you just might not find it to be the most convenient way. So see a few people writing, and that's absolutely fine. They'll give you that opportunity to make sure you got this down. So here's some tips for graphing. So there are two types of equations we have. So if it's in slope-intercept form, y equals mx plus b, you want to start at the y-intercept b, then follow the slope. Remember, that's rise over run. If it is in standard form, we want to find the x and y intercepts. You can find those using Desmos. Then we will plot those points. So we can get points from Desmos off of this. I'm going to show you how to do that as well. But here's just some tips for graphing in case you're forgetting how to graph, because it might have been a little while since you've been graphing. Here are some tips for graphing a linear equation. Because we're going to have to graph linear equations well and accurate. It's not just important that you get just a little bit of it down, be like, okay, I kind of understand it. No, we need very accurate lines graphed here. The more accurate your lines are, the better your results. That's the one flaw with this graphing method of solving, is it's so visual based that if you're sloppy with your drawing, if you're sloppy with your plotting, it's going to throw your answer off. Whereas if we solve it algebraically, you just have to be careful with your math. Drawing something wrong will have zero impact on it when we do it algebraically with either substitution or elimination, which Substitutions later this week. Elimination will be next. So see quite a few people write in. Giving you the time to get this down. Got one more big write-in thing before we get into examples. So we're going to list out the steps next. Now, the steps, I've listed them out very long. I will give you a summarized version as well, which is basically graph one line, graph the other, see where they cross. The key is when we're graphing these, it's important to only graph one equation at a time. Make sure your first line is fully graphed before you even worry about the second line, because you should be able to graph one line. Again, that's an older skill. You can graph one line, you can graph two lines. This time we're just graphing them on the same graph. So like if you had an old homework from IM1 or even in 8th grade, it was like, oh, graphing lines, you graphed a line on a unique graph each time. Now I'm saying, no, we're graphing two lines at once. That's it. That's all we're doing here. So now, here is a 3-step process. Let me highlight the beginning of each set just to help delineate where they all are. So the first step says to plot the critical points for the first equation and draw the line. It is important that you only work on one equation at a time. Again, first step, very simplified, draw the first line. Second step, very simplified, draw the second line. The step 2 says, once you finish graphing the first equation, plot the critical points for the second equation and draw the second line. So again, I'm saying a little bit of extra stuff here. It's not a big deal that I'm saying extra stuff. I'm just trying to be very deliberate here. But the basic is draw your first line completely. Once you draw your first line completely, draw your second line completely. Then step 3 says to label the XY point where the two lines cross That is the solution. If the lines are parallel, meaning they do not cross, they should have the same slope if they are parallel. But a different y-intercept, that means there's no solution. If you get two graphs that overlap completely, there are infinitely many solutions. So these are the three steps I'm going to follow on every problem today. I'm going to use Desmos to help me with critical points / my knowledge of graphing. So see quite a few pencils moving, not a big deal, just waiting for you guys to move on to the samples. We got, hoping to cover all 4 examples today. We'll see how long the first 2 take, because I do want to give you some time to practice while this is all fresh in our heads. So I might end up just doing examples 1 and 2 and save 3 and 4 for tomorrow. That's okay if that's how I do it. If I get to 3 and 4 today, that's okay too. Again, we can pivot, we can change if needed. Graph the first line completely, graph the second line completely. Let me know where they cross. And if they don't cross because they're parallel, we have no solution. If they overlap entirely, we have infinitely many solutions, meaning they are the same equation. I do also want to applaud so many of you for taking the notes by hand, because even though I did post these online in Schoology, it's better that you're doing it by hand. Here's why. When you're doing it by hand, you're actively using more of your brain because you have to think about writing it. You actually have to read what you're writing to write it down. So you're engaging with more of your mind instead of just saying, oh, I know where to find it. You're letting your mind be more active in the learning, which is great. This is the notes. Now we're going to get into examples. See this stuff in motion. Yeah. And when we're about to see these in action, if anybody needs graph paper, I do have extra graph paper, let me know. Once one right now sheet, I'm also gonna leave it right by the QR codes. So if you need more, just get it. You're welcome. You're very welcome. Yep. I have two notebooks. I'm gonna leave one over here closer to my desk, and I'm gonna leave one on the other side of the room. So depending on what half of the room you are on, you should be able to grab paper pretty easily. Please don't take the whole thing, just take out a sheet or two as you need them. Yeah. So let's start and let's get to digging in to our first example. We'll probably actually just do examples 1 and 2 based on time. This way you get a little bit of time to work today. It's a little bit of writing, sorry. So examples 1 and 2 focus on being in slope intercept form. This should be graphing you feel a little more familiar with. When it's in standard form, you might be a little more apprehensive about it, but it's really not too bad. Definitely when we use technology to our advantage. So I'm going to show you how to take advantage and make sure you have accurate graphing through Desmos and all that. So let's take a look at the first example. First example I got. Now I'm going to start with doing this purely by hand. Then I'll show you how to utilize technological tools like Desmos to help us. So if I'm graphing this, I'm looking at the first equation. What's the slope of my first equation? 2. Slope's always the number in front of x. So my slope here equals 2. That's the same. I always like slopes as fractions. I can write that as 2 over 1. So that tells me to go up 2, right 1. What's my y-intercept here? -3. So my y-intercept for the equation in red equals -3. So here's what you guys can do on Cami. -3 is my y-intercept. So at -3, put it down. Then my slope tells me up to right 1. So I can go up to and right 1 and create a second point. Now that we have 2 points, we can draw a line. So I have a line tool, Cami has a line tool as well. So what I'm going to do is I'm going to utilize that line tool. And what I'm going to do is I'm going to draw a straight line through these 2 points for as long as I can. So again, you'll be able to do that on Cami as well. So you can just draw a line. There is a line tool. I highly recommend that we try and utilize Cami for this work, because even though I said, oh, hey, work it out, paper and pencil, and taking a picture, that's great. And that is, and I'll take that work still. But if you're doing this on Cami, all it is dots and lines. You don't have to make sure like you're typing lines up if I'm trying to subtract 5 from both sides. And that's it. That's it for step 1. Before I move on to graph my second equation, are there any questions about how we graphed the first? Started here at my y-intercept and followed my slope. Not too bad, right? If you can graph one line, you can graph 2 lines. If you can graph 2 lines, you can graph 2 lines on the same graph. We just need to take our time with it. So for the second equation, y equals x plus 1. What's the slope of the second equation? I know what you're saying when you say x. Technically, the slope's 1. Thank you for getting that. The slope is 1. No, the loud knock was the first one we heard. Sorry about that. So when there's no number in front of x, that's a slope of 1. I know that's what you were getting at when you said x. I just wanted to clarify what you mean by that. So the slope is 1, so that means I go up 1 and right 1. What's my y-intercept on this one? Just 1. So I'm going to start at 1 on the y-axis, and I can just go up 1 and over 1. Again, once I have 2 points, I can draw a line. So again, I'm going to utilize my line tool here, which is something you'll be able to do on Cami if you're deciding to do your work that way. I personally would recommend it. It's going to make your life with graphing here pretty easy. Now I graph 2 lines, right? Honestly, what's the most interesting point about these 2 lines being graphed? What's most interesting about it? They meet. Exactly. That's the most interesting part here. They meet. We can figure out the point they meet is right here. Whoop, I want to change the color on that. They meet right here. So if I look at that, yep, there we go. Just making sure I'm reading that point correct. This point is at 3, 4. That is the XY coordinate there. Yep, go ahead. So let's just double check that. So you gotta check that. I don't need nobody to touch me. I work today. So there we go. That's scraping this. Actually, I think I think this might actually be closer to 3.5, comma 4.5. We'll use Desmos to check ourselves here. That's the one flaw with
How would you
graphing.
do the halves? Like, it wouldn't matter if it was half, or you just put half.
You could be like 3.5, comma 4.5. We're gonna check it in Desmos though, because it just looks the slightest bit off.
How do you do the green one?
So I started at 1 on my y-axis. I just went up 1, over 1. So that took me then to the point 1, 2. So let's take a look how to utilize technology with this. We can use Desmos to actually help us out a lot here. Nope. There we go. Graphing calculator. Okay. So here's what I'm going to do. I'm going to make a folder for each example I'm doing. So I go folder. I could call this example 1. Inside of example 1, I start with graphing y equals 2x minus 3. That was the first equation. Now, what I'm going to do is I'm going to change that to, I graphed that in red. I can change it to red in here. So I can get critical points from Desmos. So if you're graphing this with Desmos, I want you to tell me 2 critical points of the line. So I could find the x and y intercept very easily. So what I'm going to do is just quickly plot those points. 0, comma 3. And I have the point 1, 1.5, comma 0. Again, I'm going to change those colors quickly to red. Oh, I said +3, not -3. So I can quickly label those. And what I'm going to do is I'm showing you there are 2 critical points for you to graph. Now what I can do is I can graph my second equation, y equals x plus 1. Okay, that's what happened. My plotting just went a little off, plotting by hand. That's slight issue there, but not bad. Okay. So my critical points here could be -1, 0, and 0, 1. Gonna change that color to green over here so it's all matching up. So me typing those points is extra. If you're doing your work in Desmos, I want you to do. But if you're using Desmos just as support, you don't have to take the time to do that because you can just click on those and graph them yourself. Now, where they cross is 4.5. So what I'm going to do is go 4, comma 5, and I'm going to label that as the solution. That's how I can do example 1 in Desmos. So if I go back into here, let's see, I had said 3, comma 4. It looks like I was just a little bit off. Let's correct that to what Desmos said it is. Okay, looking like 4, comma 5. So my initial was just a little bit off, eyeballing it. 4, 5 is the actual answer. So we were just a little off when we graphed. It's okay, it happens. We're allowed to make little mistakes. So I'm just going to do one more example with you guys. 3 and 4, we're going to save for tomorrow. This way you'll have at least 15 minutes to work on problems similar to this with my help and support. Before I move on, do we have any questions? No, it was a little bit. Let's take a look at it.
Start at the point and then go up.
Yes, yes, you always want to start at the y-intercept.
It starts down low on the negatives, you still go up, right?
You don't always go up. You go up if the slope's positive. The slope's negative, you'll go down. But yes, you're always starting, even if it's in the negatives, you start it there and then you make your movement. So again, I got that off of Desmos. If I look, it looks close to the point 4, 5, my XY point. But when we look at more accurately on Desmos, again, when I click on where they cross, it's 4, 5. So that's how we can utilize Desmos to know we did this right. So this one, we do see 2 with negative slope. So we're going to see going down after we plot them. But let's start. What's my what's my slope for the first one? My slope, -1/2. So that tells me go down and then to the right. Now my y-intercept is 2. That's the number without the x. So I go to 2, and then it tells me to go down 1 and right 2. Look, if you're following a slope and you're like, 2 points aren't enough for me right now, go ahead and repeat it. You can repeat it actually as many times as you like to help with more accurate graphing. But when we have a line tool, that should help as well. So again, I'm going to utilize the line tool here. And there's my first line graph. Any questions on graphing the first line? We're nearly halfway done. Let's graph a second line. Graph 1, we should be able to graph 2. What's my slope here? Slopes in front of x, it's -3. So I'm going to call that actually -3/1. So that tells me I'm going down 3 and then right 1. What's my y-intercept here? Also -3. So I'm going to start at -3. Then I'm going down 1, 2, 3/1. I can reverse that. Instead of going down and to the right, I could go up and to the left if I wish. 1, 2, 3. Like so. Gonna do one more. 1, 2, 3. So I'm trying to add a few more points to make my graphing more accurate here. But really, you only need 2 points to make a line. Again, something like so. It looks like I'm crossing close to -3, comma 3. No, that's. Let me redraw that green line. Okay, it looks like -2, 3 should be my solution. You have better grids on the problems you're actually doing. So it looks like -3, -2, 3 is where these cross. So yeah, let's see. Yep, it looks like that should check out if I plug it into both. Then we can check this with Desmos. Can very quickly get to this on Desmos. And I'm going to say, take the time, call me over if you need help. So I'm going to collapse this folder for example 1 and turn that off. I'm going to create a new folder for example 2. So inside there, I started with the first equation, y equals -1/2 x. Whoop. Was +2. So there's my first one. I see 2 critical points here. I can quickly label those. So I had the point, what was that? 0, 2. And I had 4, 0. So I had those 2 critical points there. Let me get all of this in red to match my work in the notes and turn on those labels. So there's the first equation graphed. Now I want the second equation graphed. So that was y equals -3x minus 3. Okay, critical points here, 0, -3. I also have -1, 0. So again, just pull the x and y intercepts very quickly. 0, -3. Oh, 1 too many parentheses there. Not going to like that. Turn on those labels. Let's get my colors matched up. Green and green. Now what I need to do, figure out that point of intersection. -2, 3. Lo and behold, if I flip back to here, -2, 3 is what I said. So this one we were able to graph more accurately. So let's go ahead and add that point. -2, 3. And I am going to label that as the solution. And there we go. That's example 2 complete. So we do have some time left in class.